Now let's do a lab. This time I'm going to use a different approach. Measuring acceleration. What I'm going to do is, if a car has an acceleration A and it starts from rest and covers a distance x in a time interval t, then the acceleration of the car can be calculated. I'm going to give you a different method altogether. Suppose a car starts from rest and you give it an acceleration. Its speed and velocity going to increase. So it travels a distance, say x. If I can measure that distance, and if I can measure the velocity at the end of that x meter, I can then use that to calculate the acceleration. Look at this. Acceleration equal to v squared divided by 2x. Now this is what we are going to do. Now in other words, we're going to start a car. Its initial velocity will be 0. We will move it through a distance x and measure its velocity at the end of that distance x. And that will be this velocity. We square that velocity and divide it by 2 times the distance moved by the car. And that will give you the acceleration. Alright, I'll explain further. I will show you the setup. So we will allow a car to run from rest a distance x, and after running the distance x, what is the velocity the car has acquired? We will measure that velocity at the end of that distance x. Now watch the experimental setup and how I calculate the velocity. I'm going to calculate the velocity for you. Well, I will give you the information to do the calculation. Alright? Now write down the values of delta t for the next 4 trials. I'm going to show you a trial, and then I will ask you to write down the values of time for the next 4 trials and do the experiment on your own. Alright? Give me a second to do the setup. Alright, this is what we're going to do. Now, let me explain the setup for you. I have a car here, and I'm going to run it through a distance x. Now, look at the table there. I'm going to run a car through distance x, and I will write that distance over here. And the distance I'm going to run for the first time is 40 centimeter. I have a gate. Can you see this gate? This is a photo gate. When the car comes here at the photo gate, it would have run 40 centimeter. And I will measure the time taken for the car to pass the photo gate by using this equation. If you can see behind my head, the V equal to 0.015 divided by delta t. Now 0.015 is the width of this little stick, and the time taken by this stick to block the light. If you divide the width of the stick by the time taken, which will be measured by the clock there, so delta x, this is your delta x, 0.015 meter divided by that time, so 0.015 divided by delta t will measure the velocity of the car right here. Okay, so first of all, I want to go and reset the clock to start the experiment. Is that right? Okay, give me a second. Alright. Alright, I'm going to run the car a distance of 40 centimeter, and when it comes to this point, I'm going to measure the time taken by the car to cross this gate so that I can calculate its velocity using this equation. which one? V equal to 0.015 divided by delta t, where delta t is the time you will measure on the clock. Alright, I'm going to let it go, measure the time now. What is the time? Time is 0.0032 seconds. Is that right? Well, I'm going to do the first trial for you. Alright, I'm going to fill in these values. Watch me do that. The x value is 0.4 meter. Delta t is 0.0032 second. Therefore, velocity v is 0.015 divided by 0.0032. So look at that again, 0.015 divided by 0.0032. And you've got to use a calculator to do that. You get that as 4.7 meter per second squared. Meter per second is the velocity. Now calculate the acceleration. Now v squared, our v is 4.7. So come here and say 4.7 squared divided by 2x. X is 0.4. So that will be 4.7 squared. I hope you are following these. The speed, the velocity of the car when it comes here is 4.7 meter per second. So we square that velocity, 4.7 squared over 2x, 2 times 0.4, and calculate that. I got it as 27.5 meter per second squared. All right? Okay, let me do that again for you. I'm going to clear these values and let me write that again for you. Our x value is 0.4 meter, the time is 0.0032 seconds. The velocity value is 4.7 and the acceleration is 27.5. Okay, now I'm going to repeat the x values. What I'm going to do is I'm going to move the gate 10 centimeters to the right so that your x will now become 0.5 meter, 50 centimeter, which will be 0.5 meter. Okay. I'm now going to run the car a distance of 50 centimeter and you measure the time. So you're going to write, I'm not going to write again here. Your distance now will be 0.5 meter and now write down the time. Alright, so that's the time, which looks like the same. It doesn't matter. Just keep recording that time. So your distance is 0.5 meter. Your time is again 0.0032 seconds. Okay, let me now change the distance to 60 centimeter. The distance is now 60 centimeter and I want you to measure the time. So right, the third trial distance is 0.6 centimeter and I'm going to run the experiment. You measure the time. Well, the time is 0.0028. Are you watching it? The third trial is the distance is 0.6 and the time is 0.0028 seconds. Alright, let me change the distance to 70. Let me now run the 70 centimeter and the time is 0.0051. Alright, what's that time? and I'm going to change the distance to 80 centimeter for the last trial. I'm now going to run the car a distance of 80 centimeter, and now you take note of the time. Well, that's 0.0044 seconds, is that right?
Yeah.
Readings you want, I'm going to leave that for you to complete the worksheet. And